Calculus 2 for engineering students, lesson 1, introducing hyperbolic functions. Functions f of x equals half of e to the power of x minus e to the power of minus x. G of x equals half of e to the power of x plus e to the power of minus x. H of x equals f of x over g of x, which is e to the power of x minus e to the power of minus x over e to the power of x plus e to the power of minus x, are arising frequently in mathematics and its applications. That's why they have special names. F of x, e to the power of x minus e to the power of minus x divided by 2 is called sine hyperbolic of x, and it's denoted by sine hx. G of x equals e to the power of x plus e to the power of minus x divided by 2 is called cosine hyperbolic of x, and it's denoted by cosine hx. H of x equals sine hyperbolic of x divided by cosine hyperbolic of x is called tangent hyperbolic of x, and it's denoted by tan hx. The reciprocal of sine hx is called cosecant hyperbolic of x, and it's denoted by cosecant hx. The reciprocal of cosine hyperbolic of x is called secant hyperbolic of x, and it's denoted by secant hx. And the reciprocal of cotangent hyperbolic of x is denoted by cotangent hx, and it's called cotangent hyperbolic of x. In many ways, these functions are similar to trigonometric functions, and they have the same relationship to the hyperbola that the trigonometric functions have to the circle. Let's take a look at the graph of these functions. Sine hyperbolic of x is an odd function origin is the center of symmetry. It's always increasing. Its domain is all real numbers. Its range is all real numbers. For x less than 0, it is concave down. For x greater than 0, it is concave up. When x approaches negative infinity, y equals negative half of e to the power of minus x is its asymptote. When x approaches positive infinity, y equals half of e to the power of x is its asymptote. Y equals cosine hyperbolic of x is an even function. It's decreasing when x is less than 0, and it is increasing when x is greater than 0. It's always concave up. Y equals half of e to the power of minus x is its asymptote to the left side. Y equals e to the power of x divided by 2, its asymptote to the right side. Its domain is all real numbers, and the range is all real numbers greater or equal than 1. Cosine hyperbolic of x equals 1 means x is 0. Tangent hyperbolic of x has two horizontal asymptotes, y equals 1 to the right side, y equals negative 1 to the left side. It's always increasing. It's concave up for x less than 0, and it's concave down for x greater than 0. It's an odd function. Applications of science and engineering occur whenever an entity such as light, velocity, electricity, or radioactivity is gradually absorbed or extinguished. The most well-known application is the use of hyperbolic cosine to describe the shape of a hanging wire. It can be proved that if a heavy flexible cable, such as a phone cable, is suspended between 2 points at the same height, then it takes the shape of a curve with the equation y equals c plus a cosine hyperbolic of x over a. Another application is the velocity of a water wave with length L moving across a body of water with the depth of d. V would be square root of GL divided by 2 pi tangent hyperbolic of 2 pi d divided by L. The hyperbolic functions satisfy a number of identities that are similar to famous trigonometric identities. Sine h minus x equals minus sine hx. Sine of hx is an odd function. Cosine h minus x is cosine hx. Cosine hyperbolic of x is an even function. Cosine hyperbolic of x to the power of 2 minus sine hyperbolic of x to the power of 2 is 1, similar to cosine squared of x plus sine squared of x equals 1. 1 minus tangent hyperbolic of x to the power of 2 equals secant hyperbolic of x to the power of 2, similar to 1 plus tan squared of x equals secant squared of x. Sine hyperbolic of x plus y equals sine hyperbolic of x cosine hyperbolic of y plus cosine hyperbolic of x sine hyperbolic of y, similar to sine of x plus y. And cosine hyperbolic of x plus y equals cosine hyperbolic of x cosine hyperbolic of y plus sine hyperbolic of x sine hyperbolic of y. If instead of y we put x, we have sine hyperbolic of 2x equals 2 sine hyperbolic of x cosine hyperbolic of x, similar to sine of 2x equals 2 sine of x cosine of x. The hyperbolic functions satisfy a number of identities that are similar to well-known trigonometric identities. Sine hyperbolic of negative x equals negative sine hyperbolic of x. Cosine hyperbolic of negative x equals cosine hyperbolic of x. Cosine hyperbolic of x to the power of 2 minus sine hyperbolic of x to the power of 2 equals 1. 1 minus tangent hyperbolic of x to the power of 2 equals secant hyperbolic of x to the power of 2. Sine hyperbolic of x plus y equals sine hx cosine hy plus cosine hx sine hy. And cosine hyperbolic of x plus y equals cosine hyperbolic of x cosine hyperbolic of y sine hyperbolic of x sine hyperbolic of y. This can be easily proved by using the definition of sine hyperbolic of x and cosine hyperbolic of x. Using these basic identities, we can have similar identities with trigonometry. For example, sine hyperbolic of 2x is 2 sine hyperbolic of x cosine hyperbolic of x. If we assume x and y both are equal to x in this identity, or cosine hyperbolic of 2x equals cosine hyperbolic of x to the power of 2 plus sine hyperbolic of x to the power of 2, by assuming x and y equals x in this identity. Let's prove cosine hyperbolic of x to the power of 2 minus sine hyperbolic of x to the power of 2 equals 1. Cosine hyperbolic of x to the power of 2 is ex plus e minus x over 2 to the power of 2. Sine hyperbolic of x to the power of 2 equals ex minus e minus x over 2 to the power of 2. If we expand this, we have e to the power of 2x plus 2 plus e to the power of minus 2x over 4. And the next bracket would be e to the power of 2x minus 2 plus e to the power of minus 2x over 4. Common denominator is 4. We can simplify it and get 4 over 4, which is 1. To prove 1 minus tangent hyperbolic of x to the power of 2 equals secant hyperbolic of x to the power of 2, we consider cosine hyperbolic of x to the power of 2 minus sine hyperbolic of x to the power of 2 equals 1. We divide both sides by cosine hyperbolic of x to the power of 2. Then we have 1 minus sine hyperbolic over cosine hyperbolic of x to the power of 2 equals 1 over cosine hyperbolic of x to the power of 2. Sin hx over cosine hx is tan hx, and 1 over cosine hx is secant hx. That means 1 minus tangent hyperbolic of x to the power of 2 equals secant hyperbolic of x to the power of 2. Using the fact that derivative of e to the power of x is e to the power of x and derivative of e to the power of minus x is minus e to the power of minus x, we can prove derivative of sine hyperbolic of x is cosine hyperbolic of x and derivative of cosine hyperbolic of x is sine hyperbolic of x. If we write tangent hyperbolic of x as sine hyperbolic of x divided by cosine hyperbolic of x, and using quotient rule, derivative of tangent hyperbolic of x would be secant hyperbolic of x to the power of 2. Very similar to trigonometric functions. Let's find derivative of secant hyperbolic of x. We know secant hyperbolic of x is 1 over cosine hyperbolic of x. The derivative of this fraction is 0 times cosine hyperbolic of x minus derivative of cosine hyperbolic of x, which is sine hyperbolic of x times 1 divided by cosine hyperbolic of x to the power of 2. This is minus sine hyperbolic of x divided by cosine hyperbolic of x to the power of 2 minus sine hyperbolic of x divided by cosine hyperbolic of x to the power of 2 is the same as minus secant hyperbolic of x times tangent hyperbolic of x. Let's find derivative of sine hyperbolic of x2 plus 2x plus 3. If we use chain rule, we'll see derivative of sine hyperbolic of u when u is a function of x is u prime cosine hyperbolic of u. Therefore, derivative of the given function would be 2x plus 2 cosine h x2 plus 2x plus 3. Last example, we find derivative of tangent hyperbolic of sine of 2x. Derivative of tangent hyperbolic of u is u prime secant squared hyperbolic of u when u is a function of x. Chain rule. Therefore, derivative of the given function would be 2 cosine of 2x secant squared hyperbolic of sine of 2x. Next session, we are working on the inverse of hyperbolic functions. Thank you.